Holding cost per unit is $1.50 per year, and the cost of procurement is $40. No shortages are allowed, and the replenishment rate is instantaneous. Determine 1. The optimum order quantity, 2. The number of orders per year, and 3. The time between the orders. So colleagues, this optimum order quantity, please remember this, because next year we're going to learn about this in 2 courses again. So please remember this. Could you kindly mute your mics so that I'm clear now? Yes. This optimum order quantity, which is also called the economic order quantity, the main purpose of this is you are trying to minimize your holding costs and your ordering costs. Colleagues, what are holding costs? Holding costs to store your inventory. Okay? For example, if you order 100 units and to, let's say, to store your inventory, let's say 100 units, and to keep these 100 units, it's $1.50. Okay, so if you order 100 units, you're going to be paying what thing. Let me just count this up. 1, 2. You're going to be paying 150 kwacha, $150 to hold this inventory. If you increase and say, okay, I bring in 200 units. 200 multiplied by $1.50 per unit, your holding cost is going to be 300. If you bring 300 units, okay, the order cost is going to keep on increasing. The holding cost, I mean, is going to keep on increasing. Okay. At the same time, okay, colleagues, while these holding costs are increasing, there's another cost you're going to be incurring. That is your ordering cost. Okay, every time you need to make an order, this is the cost that you're going to need to incur. Alright. So, for example, you need to order. You say, okay, I'm going to order 100 units. Okay, and let's say the order cost is, this question, where is this order cost? The cost of procurement is $40. Okay, so you're going to ask, my order cost is the number of orders multiplied by the order cost. Okay. So for example, let's say your business needs this same 300 units, a maximum of 300 units on a yearly basis. If you say, okay, let me order in units of 100. Okay. So I'm going to say 300. How many orders are you going to make? That here, 100 divided by 300 divided by 100, you're going to make 3 orders. Multiplied by the order cost, $40. The order cost is going to be 120. Okay. If you decide and say, okay, instead of ordering 100 units, let me be ordering 200 units at a go. What you notice is your number of orders will start reducing. 300 divided by 200. Let's say 300 divided by 200. 1.5. Okay, 1.5 orders, which you can just round off to 2 orders. Okay, but let's use 1.5 for this case so that I show you that the order cost is reducing. The bigger the quantity we order, our order cost will be reducing because the number of orders are also reducing. So 1.5 times 40, the order cost for that will be $60. Okay. If you order, you say, okay, no, let me just order all the 300 units at once. 300 divided by 300, you just have to make one order that year. One order times $40 per order, you get $40 as your order cost. So now this is the point I'm trying to explain here. When you increase your orders, your holding costs go up. Okay, so with 100 units, holding cost 150. 200 units, holding cost 300. 300 units, holding cost 450. The more you order, your holding costs go up. But at the same time, the more you order, your order costs are going down. Because when we say, okay, if we order 100 units, our order cost was $120. When we ordered 200 units, our order cost went down to $60. So order costs are going down while holding costs are going up. So what this optimum order quantity is doing, it's trying to minimize both of these costs, the holding costs and the order costs. Okay, colleagues, that's what this optimum order quantity is trying to do. It's just trying to minimize the ordering and the holding costs, because these costs act opposite towards each other. Okay, act in an opposite manner. Any questions before I go further?
Are you able to hear me?
Yes.
So, I don't know, maybe my network was a bit bad. I just wanted to understand the question, more especially where it say the replenishment rate is instantaneous.
When you need a new order, when the stock finishes, it needs to be replaced as quickly as possible.
Oh, okay. So here we are solving the optimum order quantity.
Yes, one find the optimum order quantity.
Okay.
So optimum order quantity, this is the formula now. Hold on, colleagues. Yes, colleagues. So the optimum order quantity, this is the formula. 2 times the annual demand times the order cost divided by the holding cost. Okay. So in the question here, they told us annual demand is 2,000 units. Holding cost $1.50. Holding costs, these are costs to store your inventory, okay? Like for example, rent for the warehouse, lights and electricity bills for the warehouse, okay? Insurance for the products, salaries for the guards who are taking care of the warehouse. Those are holding costs. Order costs, the delivery expense you're charged when if the goods are delivered to you and you're paying for the delivery, that's delivery expense. If there are any people who are needed to offload, okay, the wages for those people who need, like for example, bricks, where when you go somewhere, you need also to carry people who offload and you need to pay them. Those are ordering costs. Okay, so this topic is under inventory control. All right, you're just trying to minimize your holding and your order costs, because these two costs act in opposite ways. So Q is 2,000 units, holding cost per unit $1.50, order cost or cost of procurement $40. So we're going to say 2 times 2,000 times 40 divided by 1.5. On the numerator, you're going to get 160,000. 160,000 divided by 1.5. We're going to get 106,666.666. You get the square root of this number, which is 326.59 units, which will round off to 327. So this is telling us every time we need to place an order of material, order 327 units at a time. That way you'll be minimizing your holding and your order costs. Any questions? So this is the amount of inventory we need to order. Any questions before we go to the next question, which was deposit number of orders per year? Yes, the number of orders per year is just the annual demand divided by the order quantity. In this case, this order quantity is this optimum order quantity. This is the one that we're going to use. Okay. Annual demand divided by excuse me, divided by the economic order quantity. Okay. So the annual demand 2,000. The order quantity, which is the optimum order quantity, 327. 2,000 divided by 327, 6.11, which can round off to 6 orders per year. Okay, so when we're ordering 327 units, we're going to only make 6 orders that year. Okay, I don't think it asked about the annual order cost. But if it asks for the annual order cost, it just says 6 times 40. Okay. The annual order cost is just number of orders per year plus the cost per order. That's the annual ordering cost. Okay. That's how you get it. Multiply number of orders per year by the cost per order. So in this case, 6 times 40, 240. But as I said, they never asked us to do this. Okay? That's just for your general information. Any question before we find the time between the orders? Time between the orders, how long you have to wait. Basically, it's your order quantity divided by your annual demand. Okay. So order quantity 327 divided by annual demand 2000. The answer should be in years. Okay. You get 0.165. 1635 years. Then okay, you have to convert these years to days. Okay. So just multiply by 365. Get how many days? So 0.1635 times 365, you get 59.6 days, which is also equivalent to 60 days, which is how long you have to wait when you make an order. So you have to make orders in advance. Yes. Any questions?